Welcome to 1.6 Part 1, Graphs of Functions. Today our goals are going to be, we're going to just graph any functions by plotting points, basically making an XY chart or T chart. We're also going to, this kind of is a part of this, we're going to find the intercepts by plugging in 0 for X and or Y. And then we are going to also graph piecewise functions, also by plotting points and kind of understanding how to plot a piecewise function. It has different pieces to it. So let's get started by graphing a few functions first on this coordinate plane. Here's our first function, f of x squared minus x minus 6. We note that this is a quadratic trinomial. It's quadratic because the greatest exponent is 2, and it's a trinomial because it has 1, 2, 3 terms. A trinomial, just like a binomial, is just a specific type of polynomial. So this is overall a polynomial, specifically a quadratic trinomial. All right, let's graph this. The first thing that we need to know is that when we have quadratics, they form a U-shape or a parabola. In order to see what that's going to look like, what we'll do is create a T-chart, and then we'll have x and y. Now you can write x and f of x if you'd like. Y is the same thing as f of x, but because it's called f of x, we automatically know that it's a function because this is function notation. Okay, let's plug in a couple points just to see kind of where we can start. I'll just plug in, we'll start with maybe -2 and see if that's even on here. So when we plug in -2, I need to find f of -2. When we find f of -2, once we plug in -2, we'll get a 0 out. That's cool. When you get a 0, that means that's an intercept. All right, let's plug in another point. I'll plug in a couple more just to see what this parabola looks like. All right, we've plugged in a few more points, and your calculator can totally do this for you. If you plug this into your calculator and then go over to table, or if you just go on the graph, you can plug in any x value and it should give you the output of y. All right, so once we found these points, we can plot them. All right, and I've plotted these 5 points. I know that it's a parabola, and you can always look at your calculator to 2 or Desmos to see kind of what it looks like here. So it's going to look as a sketch just like that. I didn't plug in every single point, right? I just picked 5. In general, these are a good 5 points to put in. They're not super far from 0. They're just in general a good place to start from -2 up to 2. But we have a quadratic. It opens upward. It does have a minimum point, and because we got -6 here and here, we know that the minimum point is somewhere in between, so it's symmetric, so it's at 0.5 here. Whatever this y value is, we can plug it in and see. But a couple things that I would like to focus on are the intercepts. So right here, this coordinate point here, when we plugged in 0 for x, this is the y-intercept. And we get the y-intercept when we let x equal 0. Because when you let x equal 0, you're on the y-axis. X is always 0 here. So when you plug in 0 for x, you'll get out your y-intercept, which is -6. Now it's a little bit harder to go backwards and plug in 0 for y to find your x-intercept, but let's do that and see. All right, we can see that we do have 2 x-intercepts here just from plotting it. I actually found one here just by luck, right? When y is 0, that's our x-intercept. One of them's -2. And then the other one looks like it's at 3. And so let's figure out and make sure that those are the 2 x-intercepts. The way that we find the x-intercepts are we let y be 0. We let the opposite variable be 0. So y is f of x. So I'm going to do 0 equals x squared minus x minus 6. Now, when we have a quadratic equal to 0, we do have to factor. Is there any GCF here? No. And so we can see that this will factor into 2 linear binomials, 2 sets of parentheses. There's just a 1 out front here, so this is an easy one. 2 numbers that multiply to -6 that add to -1. Those numbers are -3 and +2. If you were to FOIL these 2 back out, you would get here. So this one's factorable. Then, since it's equal to 0, we're going to set each factor equal to 0. I'll set x minus 3 equal to 0, and I'll set x plus 2 equal to 0. When we do that, we'll add 3 to get that x is 3. And then over here, we'll subtract 2 to get that x is -2. And those are our 2 x-intercepts. We do hit the x-axis at 3, and we do hit the x-axis at -2. So we have successfully graphed this function, a quadratic, because we already knew the general shape is a parabola. We can plot a couple points just to get our bearings, and then if we let x be 0, we'll find our y-intercept, and if we let y be 0, we'll find our x-intercept or intercepts. The last thing I want to do is state the domain. Remember, the domain's only restricted if x is in a denominator or if x is under a square root, and it's neither. So therefore, we can plug in anything we want for x. There we go. Our next example is graphing a piecewise function. This is a very similar idea, but this graph is just going to be split into pieces, and we can see that this graph switches what it looks like at the value of x equals 1. So somewhere where x is 1, which is this whole vertical line, somewhere along there the graph is going to go from a parabola to a line, because this is a quadratic function and this one is a linear function. All right, let's first focus on this right here. Focus on the parabola, and we need to plug in values that are less than 1. So we'll take a look at this part here, and I'll color code it so you know which one we're looking at. All right, so I need to plug in values less than 1. So I'm just going to plug in integers less than 1. I'll just plug in those 3 values, see if that gives us something. All right, if we plug in those 3, here's what we'll get. Okay, we have those 3. That's not super helpful, but here's what we do know. Because this quadratic has a negative squared term, that means it's going to open down. So it's going to look something like this overall. But it has to stop here because this parabola only exists less than 1. So let's plug in a number that's a lot closer to 1, but not quite 1. Let's maybe plug in like 0.9 and see where it is. We'll need our calculator for that. So let's plug in 0.9 for x, since that's a pretty close number, less than 1. Okay, when I plugged in 0.9, I got 3.19. So we're getting pretty close to like 3 here. Which is right here. So let's actually plug in 1, but we know we're not going to graph it all the way to 1. So let's actually plug in 1, and I'll kind of like dash it. We're going to plug in 1, and if we plugged in 1, we would get out a 3. There we go. So at 1, 3, I'm going to have an open hole, an open dot. That's because we're not actually equaling that value, but we're just very close to it. So I'm going to put the open hole there, and so I can kind of see better what this parabola looks like. It looks like that. Again, if you graph the whole parabola, it would go like this. 4 is the maximum point. It would look just like that. But we only want to graph it where x is less than 1, so we're only going to the left of 1 and not even equaling 1. We have the open dot there. Okay, let's take a look at our line, the linear part, x minus 3. And here we can plug in 1 and everything greater than 1. So I'll just plug in 3 points there. So if we plug in those 3 points, here's what it'll look like. Okay, we have those points plotted. We also know, if you think back to when you first learned how to graph lines, this is y equals 1x minus 3. So -3 is your y-intercept. And if we kept going, it would hit there at -3. And it has a slope of positive 1. So we rise 1, run 1, and continue on and just go along that diagonal there. But we can't hit here because that's not a part of this domain here. So we've graphed this piecewise function. We did understand what a x squared function looks like. We know it'll be a parabola, and we know that this is linear. Knowing those few things can really help you understand what the graph should look like. We knew that at x equals 1, there was going to be a shift in the graph. That's where the pieces part. And we have the open hole here because we're not equal to 1 here, but we approach it. And it's closed here where x is 1 because here x can be 1. Let's take a look at our intercepts. We have what looks like 2 x-intercepts. We got those just from graphing. So the x-intercepts, if we look at our graph, are at -2 and +3. And note that's where y is 0. So our x-intercepts are at -2 and +3. And then our y-intercept is where x is 0. It's at 4. And we can see that from our graph here. Let's take a look at the domain of our graph. This is a little weird, but are there any numbers that we can't plug in? Well, it looks like we can go all the way from -infinity up to and not hitting 1, But then we can plug in 1, we'd just be down here, and we can go all the way to infinity. So our domain here is still all real numbers because our piecewise tells us that we can plug in any number we want, even 1.